Thanks for watching this screencast. Our objective for this screencast is learners will be able to solve a system of equations by substitution. In the previous screencast, you saw the graphing method for solving, and in this one we want to highlight a substitution method. The basic premise of the substitution method is that you want to find a way to substitute one of the equations into the other one. So I'll show you a pretty basic example here. It says solve this system by substitution. So we've got y equals 2x minus 1 and 4x plus 2y equals negative 18. What I see right here is that y and 2x minus 1 are equal to one another. And when two things are equal, what that means is that you can use them interchangeably. So since y equals 2x minus 1, that means in the other equation here, everywhere that I see y, I could instead write 2x minus 1. So that's what I'm going to do. I'm going to take this other equation and I'm going to write exactly what's there. 4x plus 2 times y, but instead of putting y there, I'm going to put what y equals, 2x minus 1. And then I'm going to go back and finish this equation. Equals negative 18. You see that? Since y equals this, I can replace y with 2x minus 1 anywhere I need to. The advantage of that is that now my equation only has x in it, and I can solve that equation for x. I'll distribute the 2. I'll write 4x plus, this is also 4x, minus 2 now, equals negative 18. This is 8x minus 2 equals negative 18. If I add 2 to both sides, 8x is negative 16, or if I divide both sides by 8, x is negative 2. And I've found the x value that makes this system, or I should say makes these equations equal. Let's find the y. To find the y, I need to go back and use one of the equations I was given. Y equals 2 times x minus 1. But I'll replace x with the value that I know now, negative 2. And I can solve for y. 2 times negative 2 is negative 4. And negative 4 minus 1 is negative 5. What I'd really like you to do once you've done this is to make sure you write your answer as an ordered pair, just like in the previous learning target objective. So our ordered pair here would be x and then y, negative 2 comma negative 5. There it is. Here's another one that we want to solve by substitution. There is something different about this one. The different thing is that neither one of those equations is already solved for one of the variables. But when I look at this equation here, the second one, I see that I think I could solve that one for x pretty easily. If I simply took the negative 3y and made it a positive 3y on the other side. And now I've got the situation where I think I can make a substitution. If x equals 8 plus 3y, then everywhere I see x in the other equation, I can replace x with 8 plus 3y. So that's exactly what I'm going to do. Instead of putting x, I'll put 8 plus 3y. So 3 times 8 plus 3y plus 5y should be 10. And we should be set up here now. I'll distribute the 3. 24 plus 9y plus the 5y equals 10. I can combine these. That makes 14y. Don't lose the plus 24 here. If I subtract both sides by 24, what I would get is 14y equals negative 14, or y equals negative 1. And now that I know that y is negative 1, I can replace y in the other equation with negative 1. So x is 8 plus 3y would be 3 times negative 1. 3 times negative 1 is a negative 3. I get x is 5. So what's my ordered pair? What ordered pair solves this? No, it's not -1, 5. X before Y, it's 5, -1. Sometimes I'll see students mix the order of that up if they found them in backwards order. Make sure you get X and then Y. Alright, you know the drill. This one's for you. Pause the video, see if you can solve this by substitution, and then check back. The first problem you have with this system is that, like in the previous example, you've got to solve one of these equations for either X or Y. Now, I don't know that I think it matters which way you do it, because I see that I could probably easily solve this equation for X, and I could probably easily solve this equation for Y. I think that's the one that I'm going to do. I think I'm going to take this equation and I'm going to add 5x to both sides, and I'm going to say Y equals 5x minus 10, or you could do -10 plus 5x. So what I can do now is I can say, since y equals 5x plus 10, that means that in this equation I will replace y with 5x minus 10. So x plus 2 times 5x minus 10 equals -9. And we're off. X plus 10x minus 20 is -9. I believe I could rewrite this equation as 11x equals, if I add 20 to both sides, I'll get 11. Oh, 11x equals 11 means x equals 1. You got it from here? If x is 1, then that means that y equals 5 times 1 minus 10. And 5 times 1 is 5. So 5 minus 10, y is going to be -5. And I believe I've got a solution of 1, -5. And I'll leave it to you to confirm that that does indeed solve the system. As always, thanks for watching.